We're going to try a two-dimensional motion problem in which you are not given the initial velocity, but the object is launched at an angle. It's a pretty difficult problem. So we have a daredevil, and she decides to jump a canyon of width 10 meters. To do so, she drives a motorcycle up an incline sloped at 15 degrees with the horizontal. What minimum speed must she have in order to clear the canyon? We're going to assume that both sides of the canyon walls are the same height. So let's draw out the situation, which is always our first step when we do a problem. We have a ramp, and that ramp has an angle of 15 degrees with the horizontal. And then there's a canyon wall on the other side, which is where she's trying to reach. This is 10 meters across. So she takes her motorcycle off the ramp this way. I'm going to choose up and to the right as positive. Next, we need to set up our knowns, and we're going to do that in an XY chart. So we know that the motion in the X direction is independent of the motion in the Y direction. In the X direction, we're going to have constant velocity. There's no force in the X direction once the motorcycle leaves the canyon wall. There's no net force in the X direction, so the object will maintain a constant velocity, constant motion in the X direction, according to Newton's first law. In the Y direction, though, we are going to have accelerated motion because gravity is acting on the daredevil, pulling her downward at a rate of negative 9.8 meters per second squared. So there will be an acceleration in the Y direction. We don't know the velocity, so usually we would split up our velocity into X and Y components, but we can't do that because we don't know what that velocity is. We do know that our angle is 15 degrees. So I'm going to say that our velocity initial in the Y direction is equal to V times the sine of theta. And our initial velocity, our velocity in the X direction is V times the cosine of theta. Velocity in the X direction does not change. So when we lay out our knowns, we know that Vx is equal to V times the cosine of theta. We also know that the change in position in the X direction is 10 meters. That canyon is 10 meters across. In the Y direction, we know that the initial velocity is going to be V times the sine of theta. We also know that since delta y is 0, the final velocity in the Y direction is going to be the same as the initial velocity in the Y direction, but in the opposite direction. So she'll be going down with the same speed that she had when she left the other canyon wall. She'll just be moving in the opposite direction. So we also know acceleration is equal to negative 9.8 meters per second squared. And of course, we know theta is 15 degrees. We have all of our knowns written out, and we can see that we can't solve in either direction for time. And we know that time is the variable that relates both directions. So time is the same in both directions. It's the only variable that is the same in both directions. Now we need to start writing equations, and we have time, which links the two directions. We also have velocity that relates the two directions. So we have velocity in the X direction in terms of Vx, and then velocity in the Y direction in terms of Vy. All right, so we're going to use the equation delta x equals Vt, and we're going to solve for t. So we get t is equal to delta x divided by Vx. And we know that that Vx is V times the cosine of theta. In the Y direction, we can use the equation acceleration is equal to v final minus v initial over t. And our v final is negative v sine theta. Our v initial is v sine theta. And then we have t. So what I'm going to do is plug this t in here and then reduce it till we have one equation, and then we'll plug in numbers at the very end. So we have acceleration is equal to negative v sine theta minus sine theta. Actually, let's just put that together right now to make things a little easier. So we'll have negative 2v sine theta. Then we divide by delta x over v cosine theta, which is our value for t. So we can multiply by the reciprocal there and get negative 2v sine theta times v cosine theta divided by delta x. And then we'll move delta x to the other side. So we have a times delta x equals negative 2v squared sine theta cosine theta. And we're solving for v here, so we're going to bring negative 2 and sine theta to the other side, and we get v squared is equal to a times delta x divided by negative 2 sine theta cosine theta. So we can start to plug in numbers now. V is equal to the square root of a, which is negative 9.8 meters per second squared, times delta x, which is 10 meters, divided by 2 times the sine, negative 2 times the sine of 15 degrees times the cosine of 15 degrees. Now, anytime that we do this, our units should work out. So you should notice that we have meters times meters, which is meters squared, divided by seconds squared, and then we're square rooting that, so we get meters per second, which is the unit of velocity. And when we calculate that out, we get 14 meters per second. So her speed needs to be 14 meters per second as she goes off of that ramp in order to clear the canyon wall.